Hello, this is BritJet's PSX Tips, the Aerowings PSX 747 desktop simulation. Today, the first of two videos on non-precision approaches, as they used to be called, nowadays called non-ILS database approaches using an FMC. This one, Nida's then. Approaches which are in the database, but which are not an ILS. Before you continue with this video, I highly recommend you watch Final Approach for VNAV and RMI tracking. So the Nida approach, this tutorial will consist of types of approach, landing limits that we use, how to fly it, what happens on the visual phase, what to think about, and common errors. So a glance at the arrivals page will give you an idea of what approaches are available. RNAV is an independent approach of any outside aids. VOR, NDB, localizer and the others, you have to have the presentation of the aids and you have to follow them if necessary. You cannot fly a database approach if the facility is US. For example, if the NDB is US, you can't fly the NDB approach, even though the LNAV and the VNAV will do a very good job of it. You will see there is a VDZ and a VOX approach there, incidentally. Zs tend to be the preferred approach, and then it goes backwards, so it goes Z, Y, X, and so on. Just a little point on that. Localizer and back course approaches are very rare now. I'm not going to delve into those, except to say they can be flown in LNAV with the display on the ILS reversed in course so that you get a proper display. LDA approach is, of course, very similar to a localizer approach. Let's talk about limits. Use the barrow limits. You will see height above threshold limits. If you see those, then you have to add 50 feet to them, generally speaking, but I recommend you use barrow. RNAV approaches will be labelled something like GPS or GNSS. They're basically the same thing. And the approaches which are okay using VNAV are, for an RNAV approach, would be RNAV, or alternatively you can use LNAV VNAV, no problem there. What you can't use is LPV. That's a 747 incompatible procedure, basically because we haven't got a thing called WAAS, W-A-A-S, which is an augmentation system for the GPS, providing more height accuracy and also GPS accuracy. We haven't got that. You can't fly LPVs. Now they are effectively the precision element of non-ILS database approaches, which is why we tend to call approaches non-precision. Well, that's been overtaken now because LPVs are actually effectively precision approaches, hence the change in the name. Another thing on limits, as well as the altitude, might be the missed approach point. Lots of non-precision approaches have missed approach points. Here's one for JFK. When the aircraft gets to that point on a continuous descent, if you can't see to land, then you must go around regardless of your altitude. And in fact, the aircraft will fly level at that point. It won't continue the descent. A little bit about RNAV, RNP approaches. You'll see a lot of different limits here. The one to avoid is anything that says LPV, localizer performance with vertical guidance. That comes from a thing called WAAS, which is a received frequency giving updates to the GPS and updated height information. The 747 hasn't got that, so you can't use it. What you can use, however, is the other thing they've got there, which is LNAV, VNAV. You can use those limits. The lower limits on this particular runway, and you'll see it's the same runway, are for RNP. Now they will alert you for a reduction in your navigational performance, and therefore, because the alerting is available, you're allowed to fly a little bit lower. So you'll see the minima are lower for an RNP approach, and that would be your preferred minima. Now, as we said in previous videos, the VNAV profile will be lower whether flying level or down a glide slope, depending upon the temperature. And if it's cold, you will be closer to the ground. It's so much so that on some of the VNAV approaches which use uncompensated barrow equipment, and that is ours, if the temperature is below a certain figure, then you're not allowed to carry out the approach. So always have a look for the little box on the window in the approach plate to see if you are actually warm enough to fly the approach. There is one other thing you can do, and that is to consider temperature compensation at any time in the procedure, whether you're flying around the intermediate leg or elsewhere. And if you're not on radar vectors, you're just flying a procedural approach, at your discretion you can apply increases to your altitude on a cold day. This would have to be agreed with air traffic control, and the majority of countries actually don't do very much at all about compensation for temperature, but it is there and it's something to consider. Okay, so flying the approach. First of all, use the autopilot. These are very busy approaches quite often, and it's best to have your workload as low as possible. So prepare everything in advance, and we're hoping to use LNAV and VNAV. Now, if you're using a localizer approach, you would actually use localizer in preference to LNAV, but it's a minor point. You are also allowed, if it's not an RNAV approach, to use heading cell and VS if you want to, but frankly, why would you want to? So stick to LNAV and VNAV if it's appropriate. Now the big one is to make sure you set the QNH. The barometric procedures in the FMC know nothing at all about where the ground is. They simply rely on whatever reference you put in for the QNH. If you put in the wrong QNH, it will fly the whole procedure at completely the wrong altitude. So it's very important you get that right. We can use LNAV for an approach provided we've selected it from the database. So here a procedure turn, an arc, an intercept, and even a procedure hold, which will exit automatically on the inbound leg. If it's not an RNAV approach, remember you still have to monitor the raw data and follow that if necessary. As far as VNAV is concerned, provided we've checked the database, it's not necessary to do things like the DME checks that you will find on a lot of approaches. Here's an example approach showing how the FMC derives its position. We have the 3 IRS snowflakes, and the aircraft is preferring the GPS position. But also it can use, if I go to progress page 2, a nav station, in this case the localizer for the ILS. Whatever updating is taking place will be shown on the bottom right of the nav display. You see it says lock GPS, and that is the FMC's most accurate position on this particular approach. It is possible that you can get a thing called map shift. This will typically happen if there is no GPS updating, and it will happen typically after a long flight with an update from a nav station at the far end which is incorrect. This will drag the FMC out of position, and that will show up on raw data. If that happens, you can get rid of the nav station that's causing the problem by using the purge button on the 5 left that you see here. And I'll give you an example now of how to check for map shift. For the FMC to navigate accurately on a non-precision approach, you need to ensure its position is accurate. If GPS is functioning correctly, there shouldn't be a problem. If you want to check for map shift, then you use the pause button on the FS display. Press that and you'll get, depending on scale, 3 little snowflakes, which is the position of the 3 IRSs, and you can check those on the POSREF page as shown here. The little circle with the 2 ears around it is the GPS position, and the FMC will prefer that, and hence it's right on the top of our triangle. To make sure the FMC is in the right place, you compare the radials and distances that it's showing on the nav display, and I'll just zoom it out a bit. Here JFK and Delta Papa Kilo, with the display that the FMC has on its nav radio presentation. If the two displays agree, in other words the raw data from the nav display and the FMC data from the nav radio display, then your FMCs are not suffering from map shift. RNav basically means the FMC works out where it is, and it has a required navigation performance depending on what part of the flight you're in, and an actual navigation performance, which is what it's actually achieving, and it will constantly be comparing the two. It'll be beavering away, trying to stay within a 95% probability that it's within the RNP. Now the RNP, the required performance, will vary all the way from 12 miles on the ocean down to 0.3 miles for an RNav approach, and the FMC will put these values in automatically, although you can overwrite them if you want to. If the ANP exceeds the RNP at any stage, you will get unable RNP message. On the approach, if you're not flying an RNav, this need not be a disaster. You can continue to fly the aircraft on raw data, and as long as you are within the normal limits for a non-precision approach, that's fine. It's not possible to continue an RNav approach like this, however. If this message comes up on an RNav, you have to discontinue the RNav, either change it for another type of approach which might be compatible, or carry out a go-around. If you decide to continue with the approach for any reason, or you miss the message, once you get on the final approach segment, this message will turn into a caution with a beeper, so you can't miss it. So actually flying the approach, items to think about in preparation. Use the autopilot, don't be a hero. You need to have workload as low as possible. Use the maximum use of the automatics. Use LNAV and VNAV as well if appropriate. For an RNAV approach you must use LNAV and VNAV. A localizer approach, then localizer is preferred to LNAV. And in fact, as long as you're not flying an RNAV approach, you are allowed to use heading cell or VS if you prefer, but why, frankly, would you want to do that? So LNAV and VNAV is the way to go. Make sure you set the right QNH. If you set the wrong QNH, the whole procedure and final approach will be flown at the wrong altitude. Preparation on the FMC then. On the legs page, check the course and distance between the fixes, and the altitudes on the right hand side are correct, and make sure the glide path is compatible with what you want to do. And on the nav radio page, some things to look at. If you're flying an RNav approach, then the equipment will automatically select for you an ILS if one is compatible, or even a VOR. If you're flying a VOR approach, it will automatically select the VOR for you. And you will see there is a little P next to the Papa Juliet mic. That means it is procedure tuned. That's the preferred method. It means it knows you're doing a VOR approach, it tunes the correct VOR for you, and if you do a go-around, it will then carry on and tune the go-around aid as well, which is quite handy. However, if you prefer, you can overwrite that with a manual setting, and there's nothing to stop you putting some other aid in the pre-select line at the bottom. What isn't automatic is the selection of the ADFs. If you're flying an NDB approach, you have to put the ADFs in manually. On the POSREF page, you can put in the RNP if one is required for an RNP approach. Now typically this will be down to 0.3 on final approach. The system will change it automatically, so there's no need to put it in, but if you prefer, you can overwrite whatever limit you want, typically 0.3 for an RNP. When you're actually flying the approach, use the map, not one of the VOR selections. Map will give you lots more information, such as terrain, weather radar, other aircraft, and so on. And monitor the progress page number 2, because if the aircraft gets more than 50 feet low on an RNAV approach, then you are supposed to discontinue it. The golden rule for any approach like this is to configure the aircraft early. Have everything ready right at the very early stages. landing checks complete so that you can concentrate on the final approach, which is actually done as a continuous descent. Not like small aircraft going down to their limits and then flying level. Jets can't do that. You're going to fly a continuous approach. When you get down to your limits, if you can't see to land, then you go around. Anything other than an RNAV approach, you fly using raw data as your primary reference. LNAV, VNAV should do a very good job, but if they don't agree with the raw data, then you have to follow the raw data, and that might mean throwing away your autopilot LNAV, VNAV. You might have to go to heading cell or VS or something similar, or just go around. And lastly, thinking about the visual phase, and we'll come on to that presently. So actually flying the approach, similar to what you've already done, the main difference is we configure the aircraft early, get everything ready so that when we leave the final approach fix, everything is done, checklist done, everything completed so that we can concentrate on the approach. So configuration, as they say there, flap 5, flap 10, inbound, set up the system as we discussed for the VNAV procedure, speed intervention open, gear and flaps going down, landing checks being done so that you can start down at the final approach fix unencumbered by high workload. When you get to the other end, there are things to think about. Hopefully you're going to become visual, and you need to be prepared for the fact that the approach might be offset, it might be steep, for example. Could you be mistaking the runway landing on a taxiway or a parallel runway? When are you going to disconnect the autopilot and the autothrottle, and how are you going to do it? By that I don't mean just pushing buttons, I mean how are you going to configure it so that the aircraft flies smoothly onto the final approach. Have you thought about the crosswind, particularly with an offset approach? Is it blowing you onto the centre line or is it blowing you off it? Are you ready with your datum, pitch and thrust, because you're going to be hand flying the aircraft in a minute? And as you come out of the bottom of the cloud in the middle of the night, what can you actually see? What approach lights do you expect to see? Will there be any ground lighting to give you reference? And so on. Are you going to carry on to use the flight director all the way down to the ground, because it can be very compelling and it might be giving you wrong information? And do you want to switch on the flight path vector? And lastly, of course, how are you going to carry out the go-around should that be necessary? Common errors then. Not setting the QNH. That's a killer if you don't get it right. Make things easy for yourself. Configure early. Not setting VNAV correctly, and I will guarantee at some stage you will forget to select the alt cell appropriately. First of all down to your MDA and then back up to your go-around altitude. Remember that if you're not doing an RNAV approach, you must monitor raw data. If the raw data shows that the FMC is going off course, then you have to take over using heading cell or some other mode as well and get yourself tracking correctly. And lastly, of course, coming out the bottom of the cloud, be prepared for what you're going to see and how you're going to fly the aircraft. Well, I hope you found all that interesting. The next video will just be a little short demo of a flight into New York. So watch that video, and then the one after that will be about approaches which are not in the database.